Dear students, welcome to the course of electronic circuit analysis for this second year first semester, section 3. And coming to me, I am AnandaKumar, assistant professor in the Department of ECU. Coming to the course contents, we mainly deal with the common emitter amplifier circuit, where we have a BJT transistor biased with the resistors R1 and R2, and output is observed across collector resistor, and a feedback resistor RE is present along with some coupling capacitors and bypass capacitor. The main aim of the circuit is lies in two aspects. One is biasing, other is amplification. Biasing is applying DC voltage to the circuit so that the transistor is operated in active region, and the main application of transistor in active region is amplification, where we apply a small signal input voltage such as a voice signal to the circuit, and we try to observe the amplified version of the same signal at the output of the system. This is a practical example of a CE amplifier circuit or amplification circuit, where we drive the loudspeaker, which is a load resistor in this case, through a transistor, and the input is coming from a microphone, or to be specific here, from a mobile phone. And the transistor is biased by using a battery power supply as shown in the figure here. And similarly, we have some more additional circuits, such as circuits with adjustable gain. So where a gain is nothing but we increase voltage gain or current gain through some setup so that the output amplified will be more. There are several number of such kind of example circuits which a student can build easily, which can be summarized in this screen. Coming to the practical application, we aim to design a chip where in BJT, say NPN BJT, the diffusion process is as shown in this figure, and well, advanced MOSFET technology, where N-channel, typical N-channel MOSFET consists of a source, drain, and a gate, where the gate is used to control the flow of electrons from source to drain. This is a typical layout of a transistor, and we want to make a chip such as a layout such that the end product is a chip. Coming to the overview of ECA, Unit 1, we start with single stage amplifiers, and we move on to the multi-stage amplifiers to improve the gain in second chapter. And we deal with high frequency response of amplifier circuit in chapter 3. And specific application, which is a public address system, is deal with power amplifiers in chapter 4. And consequently, we end up with chapter 5, where we take a feedback of this entire amplifier circuit, which has been shown previously, C amplifier circuit, and we see the application of oscillations as well. Coming to the outcomes, upon completing this unit 1, a student should be able to analyze this low frequency response of the given circuits and its small signal behavior in terms of we derive a few parameters such as current gain, voltage gain, input resistance, and output resistance for a BJT amplifier circuit as well as MOSFET amplifier circuit. In case of BJT, we use a H parameter model. And again, we have two kinds of analysis. One is exact analysis as well as approximate analysis. Similarly, we have other course outcomes which we discussed as and when the unit has come. Specifically in Unit 1, we have learning outcomes again. Upon completing Unit 1, students should be able to classify what are the different kinds of amplifiers, so which is subjected to the Bloom's level understand. And the student should be able to derive these amplifier parameters such as voltage gain, current gain, input resistance, and output resistance for given BJT amplifier circuit using exact analysis and approximate analysis. And for MOSFET, using MOSFET also, the student should be able to derive or analyze this circuit parameters. Coming to the textbooks and reference books, Integrated Electronics by Millman and Hagias is a standard reference book. And we also have a Boylsted and Cedar-Smith test books in order to follow. More practical circuits can be found in these test books. So summarizing in Unit 1, the key highlights includes classification of amplifiers, and we start with BJT, which is as shown in the first part of this figure, BJT small signal analysis. We replace in small signal analysis, and BJT is replaced with a linear circuit, because BJT being a non-linear element in a circuit to analyze and get a conclusions of the parameters, we need to replace this BJT with some linear equivalent circuit. Linear equivalent circuit is, in this case, is H parameter model with exact or approximate we can do. And similar MOSFET device can also be replaced with its equivalent small signal model, and we start analyzing for a particular single stage. Single stage in the sense we typically we take only one transistor in the circuit. Now consider as a whole, consider this as a two-port network where the transistor with proper biasing has been considered in this particular block, and we have we apply input signal through this Vs voltage source, and we have some source resistance at the input side, and output side we connect a load resistor, which is a load loudspeaker, say for example, and we observe the output over here. And for the transistor amplifier, we have input resistance, which is Zi, output resistance R0 or output admittance Y0. We also have voltage gain and current gain for a particular transistor amplifier, which we need to analyze. So in this process, we replace this block diagram with BJT. And to be particular, in exact analysis, we replace with this H parameter model, which is shown with this green color circuit. And input and outputs are shown as usual with the red and blue. In case of approximate analysis, this exact analysis model is replaced, H parameter model is replaced with approximate analysis model, where we have simply a resistor at the input side and current source at the output side. We also analyze the circuit for all the three different transistor configurations for common emitter, common base, and common collector, along with emitter resistor and without emitter resistor also we analyze. Every time we replace the transistor circuit with this equivalent model, and we start deriving the required parameters. So summarizing the whole unit, by using exact analysis, we have a current gain and input resistance, voltage gain, output admittance in a generalized form. If it is a CE amplifier, we put the suffix E. CB amplifier would give the suffix B for the H parameter, and CC amplifier we put the suffix C. In case of approximate analysis, we have because HO output admittance as well as HR reverse voltage gain are very less in value, we will neglect them, and accordingly we have approximate formulas for approximate model with some minor trade-off with accuracy and complexity. And coming to the summary of BJT amplifier analysis, we have we particularly one configuration cannot play a role in all the applications. Say for example, CA amplifier, it will play a major role of increased current gain as well as voltage gain. CC amplifier offers high input resistance and low output resistance, and it also acts as a buffer. Whereas CB amplifier particularly used for high frequency applications. So depending upon the trade-off and applications, we use these circuits as and when needed. Now, coming to the second part of the unit 1, we have a MOSFET, which is metal oxide semiconductor field effect transistor, where we apply some field through the gate and we control the current flow from the source to drain. And hence it is called metal oxide semiconductor. A pedagogy has been explained in the class, where a MOSFET model has been designed using thermocol sheets, which has been encouraged through the students. The students are also thoroughly enjoyed the session, where they could see the source as well as drain, and how the bulk is operating and how the gate will control the flow practically, physically. And coming to the analogy between BJT and MOSFET, the BJT every time we try to control the flow of current from either emitter to collector or from source to drain. So in BJT, there could be a slight touch which can result in a leakage current, but this is avoided in MOSFET, where oxide acts as insulator, and through some touch, the current flow, the water flow from a tap can be controlled. So coming to the leakage current or switching speed, when we consider compared to BJT, MOSFET is advantageous. That's why most practical circuits, even though BJT is invented around 1950s, right now the technology has been built on MOSFET technology. Coming to this MOSFET classification, we have either enhancement or depletion, again N channel and P channel depending upon the construction. In this semester or in this particular course, we start learning through N channel MOSFET, where the symbol has some oxide. If we consider the bulk also, we show the symbol with bulk with this arrow in the middle, or simple as that, we can show it as a NPN transistor as N channel MOSFET. Coming to the characteristics, we have drain characteristics as well as transfer characteristics of MOSFET, which will be dealt in detail. And coming to the equivalent circuit of the MOSFET, because of the oxide at the input control between the gate and source and drain, input resistance is infinite, which means input current entering is zero. But how come the output will be controlled through input voltage source, which is nothing but VGS. This GM, transconductance, which is a parameter that relates the input voltage to the output current, which is a ratio of output current to the input voltage, will tell how better the signal, how better the transistor is used to control the flow of current from source to drain. Similar to the BJT analysis, we replace this MOSFET symbol with its equivalent model, and we start analyzing the parameters of interest. That is what small signal analysis. So coming to the conclusion, mainly we deal with the small signal analysis, which means very small fluctuations around the Q point we'll observe. And particularly for the low frequency, we replace the BJT with H parameter model and MOSFET with its small signal model, and derive the important parameters as current gain, voltage gain, input resistance and output resistance, and summons. Thank you.